Hello everyone, it's Sofox again, and this time we are doing the Arduino Starter Kit, Arduino Projects Book, number 05, Mood Cue. And honestly, there's not much mood. I mean, the other thing was a love detector, and that was just temperature. But this is less a mood cue and more of a excuse to mess around with potentiometers and servos, which is the fun part. So the servo is basically this little thing here, and I'll just take it out in advance. A servo is this. It's a little like a motor, except instead of spinning round and round, it will spin within a range of 180 degrees. You know, so forward and back. But the great thing about this servo is that you can set it to any angle specifically. You can set it to like all the way in one direction, all the way in the other direction, or any point in between. So like, I guess windscreen wipers is a good example of a servo, I suppose. Or anything, or, you know, anything where you're trying to like move a thing around by a certain angle, I suppose even. So, let's just dive in. Once again, here is our diagram. There's a couple of elements here. First thing we do is take our beloved thing from last time and yank, of course, all the connections out of it. Okay, I'm just going to disconnect it at the computer end of things. Wait, which is the... Okay. Screw it. Okay, so here we go with the photoresistors. Here we go with all those nice 220 ohm resistors. Here's a couple of extra cables that we may or may not need later. I'm just going to take out these cables because these are the ones, the analog. I'll probably need at least one of these later. And take out the 10 kilo ohm resistors, and we can take away our light that's got 3 lights in it. Okay, so this is a pretty simple thing. I could take out those, but I decided, well, I better just make 100% sure. If I leave in connections, then there's a chance that I'll accidentally short circuit it as I put something down that I didn't mean to put down. But I'll definitely leave this one here because, you know, that's always live, and this one over here is ground. So let's start it up. They say yes, hook up the ground and voltage, which we've already done. And then of course we've got this here. Now, basically this is a bit of a tricky thing, so let's go with this. Actually no, why don't we start with the servo, because that's really the reason we're all here, or at least the reason I'm here. The point is, I really like servos, okay, and I really kind of want to play with this one. So, we've got a couple of things here, we've got a couple of connections, but I think I'll make it this one here because I just like having a thing that sticks out. Now, just so it'll stick out even more, I happen to have a little bit of plasticine here, so I'll just stick it on the end here so you can all like really see this nice little blue thingy. Probably used too much plasticine, whatever. So we've got to stick it down here, and basically, as you can see, there is a red, a white, and a black. So obviously the black and the red are you know, current and voltage. They're the things that you keep going in any regard. Now, as it says here, similar to the way you use pulse width modulation on LED on a color mixing project, servo motors expect a number of pulses that tell them what angle to move to. The pulses always come at the same time interval, but the width varies between 100, 1000 and 2000 microseconds. While it's possible to write code to generate these pulses, yeah, basically Arduino comes with stuff that lets you do all that yourself. So, in order to plug this in, we actually need to change a female to a male, and let me just make sure I've got this the right way. Yes, so I need to snap off 3 of these. Success! And stick these in here. And I think I'm going to push them up enough so they actually go in there. Hang on. Okay, let's keep trying this until it actually works. Okay, something's not working here. I think I need to push the... Okay, what is this? Seriously? Okay, this is the part I get stuck on? Seriously? Ugh. There. Remember, sometimes it's a delicate operation. Sometimes you use brute force, and sometimes now I've accidentally made tiny impression marks on my book. But the point is, this is connected in, and now I can connect this the right way. Now according to this, the black is at the top, and then there's the red, and then there's the white. So, except this is completely wired differently. This has got white in the middle, red at this side, and black on that side. Great. This is why you can't always follow directions blindly, because as fun as that might sound, sometimes the directions are terribly, terribly wrong. Yeah, this again. Yeah, damn it. Okay. So now that we got this more or less in, okay, which one? We'll make black the top because that makes the most amount of sense. Now, so black is at the top, and then we simply connect the black top to black. So that's 26, and there we go. So next up, we connect the next little bit, which is voltage to the far thing. So yeah, red definitely comes out in the bottom in this one, and red definitely comes out in the middle in this one. I think then, so we'll just have to deal with this. Damn it. I can do this. I believe in myself. For just sake. Okay, so one into plus, which is voltage, and one into the red thing. So that means the white thing in the middle. So the white thing goes all the way up to number 9. 1, 2, 3, 4, 5. Sorry. 27 goes all the way up to number 9. Now, this is going to be the next important bit here, because if you notice, the instructions have capacitors on them. As you can see here, it says plug 3 male header. Yeah, plug 3 male headers and females into the servo. Okay. When your servo motor moves, it draws more current than if it was already in motion. So in other words, when you start up, it takes more energy. This will cause a dip in the voltage on your board. By placing a 100 farad capacitor across the power and ground right next to the male headers shown in Fig 1, you can smooth out the voltage changes that might occur. You may also place a capacitor across power and ground going into the potentiometer. These are called decoupling capacitors because they reduce or decouple changes caused by the combinations from the rest of the circuit. Now, the Arduino Starter Kit comes with 3, but you got to pay attention because they're all slightly different values. These two are 100. This one is only 25, but I'm not sure if that makes it a larger. I'll just start with the, okay, I forget what the U means, but the 100 one. So let us try to extract this capacitor from this package without breaking it, and hopefully we will be at least mildly successful. Now this is the important part. You gotta make sure that the negative stripe is on the negative end. Otherwise, according to the instructions, if you put the capacitor in backwards, they can explode. Well, that's comforting. Negative to here, and positive to positive. Damn it. Okay, let's try that again. So as you can see, the bottom part is the positive and 2 up is the negative. So I just got to stick this one. I've just got to stick this one, oh, there we are, in, and the other thing, there we are, kind of, sort of, come on, you can do it. Let's just say that that'll work for now. Okay, so, we've got this, we've got our servo. Why don't we just skip ahead to the code writing, just to at least get the servo working. And okay, so, first of all, let's get rid of our previous project, the color mixing lamp, and make the new one, which is a, yeah, actually I've already revealed this, so mood cue. So MODCUE. So let's start with the basics. We have to include the servo, unless we want to like code all the exact timing ourselves. we need to hash include and then se or vo dot h. Perfect. So now we define a servo. Servo, my servo. I could just call him Tom, but I don't know how many would get that. And then we have to, oh, there's other stuff. But basically, let's set up the server right here. And my servo dot attach to 9 and 9. And we'll just include the serial dot begin because we'll probably be typing more text into the screen later. So here's the real thing. We write the angle. My servo dot write. That's it. myservo dot drite. Now, apparently when you write it, it can be an angle from 0 to 180 degrees. So let's start with a very simple angle, 0. And apparently you're meant to move the motor. Finally, it's time to the command server moves the motor at the angle you specify. At the end of the loop, put a delay so the server has time to move to its new position. So we'll give it a delay of, yeah, give it 100. So it's going to move to 0. Then let's move it to at a right angle. And then let's move it back to 0. And then let's move it to 180. And that's a really, really nice program. Yep, okay, let's see if this works. Okay, so here we have our nice little servo here. Everything's hooked up. I've already plugged it back in again, so it's hooked up to the computer. Let's just run the program that we've just written, and let's see if the magic happens. By magic, I mean sufficiently advanced technology, but you already knew that. So it's compiling and uploading, and come on, move my beautiful servo, move! Anytime. It's fine. No rush. It's not moving. Okay, so why isn't this servo working? Well, it's a question for the ages, my friend, and unfortunately we don't, that's all the time we have. No, I'm just kidding. Alright, let's see what is up here. I could theoretically have miswired everything completely. I hope I'm not that incompetent, but, you know, there's always that chance. Alright, so, white wire here. Yes, I know, I'm just jamming it directly in. I don't care. I'm skipping the capacitor completely. Whenever you've got a problem, the first thing to do is reduce the complexity of whatever is going on so that you're more easily able to identify what is going wrong. Okay, that's not working. Am I going to do this? Am I going to try every combination? Oh, that actually worked. Dear gosh, what if the layout earlier, I said the layout was wrong, right? I said first of all they had the black and then the red and then the white, and instead it had the black and the white and the red. It's a different ordering. But what if the ordering is right? They just messed up the colors. In which case there's the black and then I put the red and the server control comes in last. So this comes, yes. So the first wire is the black, then comes the red, and I heard it. What? Once I get this done properly, here comes the red. Yeah, into 5 volts you go. Now, I heard a whine, which makes me think that I'm onto something with this. So now I've got to hook it up. Well, let's try to... Yeah, damn it. Okay, just here we go. What? No, it's gone. No. It was whining there a second ago. I thought we had something. What happened to the magic? Okay, there we are. Now, quickly, in here. No, nothing. No. Okay. What is going on here? Okay. Okay, here we go. This in here. I'm going to try every combination. Nope, that doesn't work. So what if it's here? And it's this and this. Nope. Ah, dear gosh. This is probably not how you're meant to do this, but I have no clue where it is, what it's meant to do. This is not how you're meant to do electronics. You're not meant to just plug them in every random combination. At least have the capacitor out, because if I put that in the wrong way, it would be bad. Okay, let's go back to basics here. This is black. And so is this. So black is most likely there. So, if black is most likely there, then that's either the combination is that way, which it isn't, or the combination is here and here, which it's whining, but it's not doing anything. Why is this not working? Please tell me why. Why do birds sing? Okay, okay. Let's think logically. This. Oh, wait. How long does a delay last? Sugar. Give me a second here. A delay. Okay, Arduino delay command. Let's see now. Arduino delay command. A delay. Yeah, it's in milliseconds. Okay, maybe I'm doing something completely wrong here. In fact, most likely I am. I'm changing everything to 1 second. Every time I put 100 there before. No, wait. The first thing to do is to take something that we know is ground. Now let's make sure we get the right ground. Yeah. So let's restore this back to being ground and this back to being plus. Because after all, actually, like having a consistent standard is going to make it much easier to figure this out. Next, let's take a standard light. There's the negative end, so I put one end here, one end here. And let's see what happens when I just take the servo and just apply some current to it. Absolutely not. Have I? You are kidding me. I did it again. I plugged it into 8 instead of 9. This whole time. See? Now it's flickering on and off because it's sending commands. There you go, my friend. That's how it sometimes happens. Okay. So now that it's kind of, sort of working, let's plunk this down here. And let's plunk. Let's see. So this is, yes, this is positive. So let's plunk this down and see if it actually works. Oh, it kind of does. I think the problem is it's taking about a tenth of a second, and then it's switching between all the commands, which is probably not good. So I'm gonna go back to the board and change everything. Oh, damn it. Okay, how do you make it stop? All right, of course, I should know this. Okay, I'm gonna make a quick change. If you recall, I made everything like 100 millisecond delay between everything. But I'm going to change that. Excuse me for the weather. I'm going to change it so now everything is 1 second to speed it up. Excuse me with that. And here we go. There we go. Okay, that's 0. That's 180. Oh, that's 0, 90, 0. And that's trying to get to the 180, then going back to 0, 90, 0. All the way to 180 and then back. There we got it. We've got a moving servo that actually moves according to our set of predefined commands. Now servos respond to this. They're actually sensors or something that send feedback or something. I'm not sure. The point is, servo is smart enough to know which direction it is pointed in all the time. Yeah, just again, 90, 0, 90, 180. No, sorry. 0, 90, 0, 180, then I think it runs out of time to do that. Okay, I'm upping it to 2 seconds. So, I'm going to upload these changes. Basically the same as before, just instead of a gap of 1 second, it's now 2 seconds. So, 90, 0, 180, which actually doesn't feel like a full 180. It kind of does, I guess. So, 90. So the pattern is there. Sorry. Yeah, there we are. Cool. So now we need to hook this up so it actually does something a bit more than this. So first of all, we cut the power because now we need to go back to completing this, and the first thing we do is we set up a potentiometer because this thing has potential. Here is a potentiometer. So put it here or somewhere, or I'm trying to figure out the best way to do this. Because it's actually, it looks bigger than it does in the diagram. I mean, it seems to imply that you can put one bit of the potentiometer in one column and the next in the other, but clearly they almost want you like doing it across. Okay, I've already decided what I'm going to do. We're going to put this potentiometer right across the thing, even though it's technically not on the instructions, but the instructions show a different potentiometer. They've already betrayed us once with the ordering light cable thingamabobs. They're not going to betray us a second time. And then here is the potentiometer bit, the twizzly bit, as I call it. This is going to be very important. This is, it's like a volume thing. In fact, volumes are, in a lot of things, a volume is a potentiometer of some description. All a potentiometer is just, all a potentiometer actually is just a variable resistor, really. So we get one negative to one side and one positive to one side. So negative to one side, and then positive, and I'm actually sort of following convention this time. Excuse me for the wind, it's been, I've had some words with it earlier, but a rather gusty discussion, but okay. And here's where we go again. We need the capacitor, just to make sure, well, we don't need it. You can probably do it without the capacitor, but it's just preferable. Now, once again, while we like explosions, we don't want to blow this one up. So, -1 goes into negative, positive into positive. Okay, so negative, negative, positive, positive. One last thing, and that's we've got to take this potentiometer to, where do we take it? Oh, to A0. So remember in a previous exercise we were reading A0, we were reading analog input, and this time we're doing it at, okay, do we have a longer cable? Yes. A0 all the way to there. So the way it works is voltage goes in one side and comes out the other, and by twisting this you determine how much of it's a voltage divider. The voltage is going to take place across this section, but by twisting this you decide whether the voltage that's here is more to the high, in other words really high, or more to the low. In other words, you change the voltage. It is really as simple as that. The voltage of this, which gets read up by that. So now we got that bit done. Let's go back to the code and whip up its interactions. Okay, so let's get rid of some of the server code and get into the real nitty-gritty of basically how you get the potentiometer, which is still here, and use it to control the servo. So int const pot pin A0, int const pin equals A0. Now that just means the potentiometer. It doesn't mean something else that you may imagine. Int pot val int angle. Great. So the loop that we're doing is actually pretty straightforward. First of all, we read what the voltage of the potentiometer is. Pot val equals analog read, and then the pot. Okay. So we basically, as I said, when we twist this back and forth, it'll change the voltage that goes out to this wire here, which is read by A0. So the value that we read will be between 0 and 1024, or 1023, my mistake, I apologize. So actually, first of all, we just do a serial print. Dot print So why don't we just start up the standard thing and open up the serial monitor and just see what this... Okay, apparently we made a mistake somewhere. Alright, our mistake was not plugging in the board in the first place. Okay, no, you don't need to keep going, little thing, we're already moving on to something else, kind of, sort of. There we are. So, we've uploaded a new thing, we're looking at the serial monitor. As you can see, it looks like it's 1023, meaning that the dial is pretty much all the way over to 1. So, allow me to twist, like we did last summer. And it's still 1023. Let me twist in the other direction. It's still 10. What the fudge? Seriously? Why is this getting such inconsistent readings? This is definitely A0, right? Okay, why is touching it moving? This is not how it's meant to work. Okay. Is this still trying to go? For fudge's sake. Okay, let's try this again. Okay, 10. No, you shouldn't be moving. Okay. Okay, that's 0. That's 0. That is kind of working. And I ult to the other side. Okay, now let's go halfway. Yes? Yes! It is working! I'm twisting it halfway now, and it's roughly halfway. So let's move it slowly downwards. Which it kind of is working. Yes. Ooh. Oh. Now why is it jumping up? It should be... Something going wrong here. I think there might be a literal loose wire here somewhere. Okay, 1023. Let's move it in the other direction, and now you're not... What is up with this? I need it to be less sensitive than this. Maybe I've got it the wrong way, maybe this isn't in properly. There we are. Or maybe... There we are. Come on, you can do this. I believe in you. Okay. Okay, so that kind of works. Damn it. Okay, what? I'm switching to a different one. This is just getting messy now. So, let's try it. And just like the last one, we put this one here and this one kind of here. There we kind of go. That kind of works. Get in there. So that's probably what happened. I was just probably didn't have it securely enough in. We stick our little thing in there. Okay, it's consistent. We're getting about 500. Let's move it one side. Now we're getting consistently 1023. And all the way to the other. Now we're getting consistently pretty close to 0. This is good. Hooray. Thumbs up. Here we go. Okay, let's try to hit 200. Oh. Yeah. Yeah, there we are. Let's hit 900. Oh. Close enough. Yeah. There we are. Now let's go to 0 and then back again. Yeah. Yeah, and all the way back. Okay, cool. This is working. This is copacetic. So now that we've known it, the value of it, we've got our value from 0 to 200, 1023. But the real question is, how do we convert this into a value that can actually be a degrees? Because if you remember, the range of the servo was 0 to 180. Well, I'm glad I asked that question, because there is a function that they provide to help you do this exact thing. It is called map. And what it does is, first of all, you enter in the value that you want changed. Hot val. And then you enter in what the range of that is. Remember, it was 0 to 1023. Yes. And what we want it to come out is a value between 0 and, well, 179. The book said, I thought it was 180, but the book says 179, so I'm just going to go with the book in this case. Even though it's often right. And that's pretty much it. It's a simple mapping operation. If you remember in the past we had to divide something by 4, you know, it was like we had to get something from 1023 to from 0, you know, and basically get it from 0 to 255. We theoretically could have used this exact function with 255 here instead of 179, or else we could just do a really nice divide operation, you know, dividing it by whatever 179 over 1023 is, and then, or multiplying it by that. And the point is, this function makes things easier and easier to read and less cryptic. So we've got the angle. Now I could serial print out the angle that we get, but you know what? We've had enough of that little thing. Why don't we server.write.angle and then move this delay down to 115 because the server needs a bit of time to change. Save. Alright, now let's see if we've got the end result. Here we are again, and this is the moment of truth. Did I upload? Yeah, I saved, but I'm not sure I uploaded. Okay, now I'm uploading. So this is the moment of truth. We've got it. So this potentiometer here is rigged, so whatever value of this, it will get converted into a value for this. So let's see if this actually works. Oh, nice. Okay, all the way to this side, cool. Now, all the way to the other. Nice. That is cool. That is really, really cool. You can do a lot of things with servos. I probably even haven't touched the basics. For instance, you can play a really, 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 really simple game of football. There we are. Let's imagine the goal is in vaguely that direction. Yeah, there we are. Yeah, let's imagine that this is the goal thing, and he leads up. He comes up for the strike, and okay, he's kind of new on the team, but we can do better. Go. Okay. Thankfully, the defense is asleep on the job, and yay, goal! And that is one of the most wonderful things you can possibly do with a servo and potentiometer all linked up like that. It's pretty damn cool, I have to say. So that's all the way in one direction. That's all the way in the other direction. And every time I twist this, I can just set a new angle. Now, the actual manual suggests, or not manual, instruction things, that you do some nice little complicated things with, like, you know, having an arrow and saying, come in, please knock, stay out. You can definitely do some things. I've seen variants on this that basically use it to throw things at you, but I'm not sure this is a fast enough acting one to actually throw stuff at us. It seems pretty stable, pretty strong. Yeah, I mean, this is definitely one of those things where your imagination is the limit, so I hope you've got a good imagination and you haven't ruined it just by constantly watching TV the whole time. Anyway, I think that I'll leave it at that for now. End up with a pretty cool note. So this has been Sofox. This has been chapter 5 and of the going through the Arduino. Hope you enjoyed, and all the best.